All right. Hello, everyone. Welcome back to SDSS 2024. Now it's time for us to move on to our next thematic session, which is about geoprivacy challenges and solutions in the digital society. Now, Hongyu, the stage is all yours.
Thank you so much, Ray, for your introduction. So welcome everyone for our afternoon session on the topic of geoprivacy challenges and solutions in the digital society. Okay, let me move to the next slide. So today we have our wonderful panelists joining our discussion. First of all, we have Dr. Yue Lin, who is an assistant instructional professor from the Center of Spatial Data Science at the University of Chicago. We have Dr. Grant McKenzie, who is an associate professor from the Department of Geography at McGill University. Myself, who is a lecturer at the Department of Earth, Geographic, and Climate Sciences at the University of Massachusetts Amherst. And finally, we have Yifan Yang from the Department of Geography at Texas A&M University. So welcome everyone. To get us started, we're going to invite Dr. Yue Lin to speak of geo-indistinguishable masking. Yue Lin, the stage is yours.
So good afternoon, everyone. Thank you all for joining the session. And today I'll be sharing my work on geo-indistinguishable masking. I'll briefly walk you through this approach and its application. Mapping has a history of being an important activity for many social science applications, and this includes health, population, and transportation. One important example we know is John Snow's cholera map, which illustrates the locations of patients and water pumps to help reason the cause of cholera in London. Over time, we have increasingly advanced technologies to locate individuals on the earth through GPS, indoor navigation, and Wi-Fi, and has greatly enhanced the precision and details of maps we can create. However, mapping individual location is often associated with the risk of privacy violations. Specifically, by pinpointing location on a map, one may be able to reveal someone's identity without the consent, and can be particularly concerning if the map is about vulnerable populations such as patients, racial minorities, and refugees. So, to enhance privacy protection in mapping since the 1990s, there emerged a large collection of methods for geomasking, which use different ways to display the original locations of individuals to prevent re-identification. So this collection of methods extends from simple random perturbation to more advanced methods, such as multi-scale masking and location swapping. So as I've just mentioned, the existing geomasking methods, they are based on the concepts known as spatial K-anonymity, and these privacy concepts has a limitation because it's not. It may turn ineffective if site information such as land use, road networks are presented. And even if we can incorporate some specific site information into the geomasking methods, such as land use and parcel boundaries, something like that, these approaches may also fail when we don't have any auxiliary data, especially in the global south where public data sources are more limited. And also, these methods are not time-proofed for any site information available in the future. So in order to address this issue and to improve on existing geomasking methods, I leverage a recent privacy concept called epsilon geo-indistinguishability to improve geomasking methods. So epsilon geo-indistinguishability protects against adversaries with any site information, regardless of whether it is currently accessible or may be obtained in the future. So it ensures that for any two locations within a radius R, their probability distributions remain close even in the presence of auxiliary information. And it also ensures decreased indistinguishability as distance increases to maintain data utility. So the improved geomasking methods proposed in this study called geo-indistinguishable masking. So there are two steps for these methods. The first one is to be able to define a masking area. And a very simple way to define this is to base on the k nearest neighbors. So for each point that we want to mask, we will define a masking area around it. And then in the second step, within this masking area, we will determine the optimal mask locations based on geo-indistinguishability. And this involves using an optimization model. So the objective of the optimization model is to minimize the expected distance displaced. And we use geo-indistinguishability as one of the constraints for this optimization model. So our goal is to maximize our data utility while ensuring that we apply the geo-indistinguishability methods to ensure privacy protection. So this is a comparison of the masking results with varying parameters that provides different levels of protection. Again, here K is the range of the mask area, epsilon is the geo-indistinguishability parameter. And as you can see here, with a larger K value and a smaller epsilon value, there will be higher privacy protection provided. And thus the mask points will be further away from the original points. And I also compare the utility of the mask data with two other geomasking methods, location swapping and random perturbation. So the results here shows that geo-indistinguishable masking can also effectively preserve spatial data of the spatial pattern of the data by ensuring the smallest distance displaced from the original locations, and also the smallest difference in other measures such as the difference in mean nearest neighbor distance. So as a summary, this paper proposes a geo-indistinguishable masking methods to address whether we can safely present useful address or point level spatial data while still be able to preserve the location privacy of individuals. And these methods, so one of the biggest advantage of these methods is that it protects against any arbitrary site informations that are available to attack the spatial data. And it also preserves the spatial point patterns even compared to existing methods that only provides weaker privacy protection based on spatial K anonymity. So for future work, we want to be able to improve these methods to be applicable to mobility data where the points are temporally correlated. And also these methods, although it ensures stronger privacy protection, but it does involve higher computational complexity. So there are also rooms for improvement here. So this is a link to the published work, and thank you all for joining the session. I apologize for the disruptions, and I welcome any questions.
Thank you very much, Yue. Do we have any quick questions? All right. So while we are waiting for Grant to share his screen, maybe Yue, you can answer one of the questions from the audience. I think the question is asking about HIPAA compliance, right? Yeah.
Yeah, thank you for the question. And I think when I was designing these methods, I also checked the HIPAA, and yeah, unfortunately, there are some mismatches between the technical improvements we can make and the regulatory requirements, but in my use cases, I apply that to the census data. So I think the Census Bureau, especially in the US, they have been looking for ways to release more detailed data, but they also have a legal requirements to prohibit identifying an individuals in their data set. So I think the geomasking methods are one of the ways they're looking at to release confidential but useful data. So that's my use case. But of course, I think in health data, there are some different like regulations there, and yeah, but I think there are future work that can be done to better match regulatory requirements in health. Thank you for your questions.
Thank you, Yue. So our next speaker is Dr. Grant McKenzie, and he will be talking with us about beyond spatial privacy towards place-based privacy. Grant?
So yeah, I just quickly wanted to talk about sort of place-based approach to geoprivacy. This is some of the work we've been doing for a while. It's actually work that I did with Hongyu over the last year or so, just to give a sort of recap of this kind of stuff that we've been doing. Basically, the ideas that we take, or I'm taking towards geoprivacy, is to really think about context, really. So not just purely focus on the spatial dimension of the latitude, longitude, the vertical dimension or anything like that, but also consider the other dimensions of space and place. So there's a long history, we know, of place-based research, predominantly coming from sort of social critical theory kind of areas, but increasingly we see a lot more sort of adoption of this in the computational sciences or spatial data science as well. And I like to think of place as sort of multifaceted. So space is really one, or rather three dimensions of the concept of place, but there's piles of other dimensions, temporal dimensions, sights, smells, sounds, all the things that go into understanding a sense of place or understanding of place. And increasingly, we're able to access this sort of these concepts of place or different dimensions of place through the data exhaust, right? So the data that's created as our digital lives interact with our physical world around us as we use our mobile devices and on various IoT devices and sensors. And all of this data is being collected, often being data siloed into certain companies' data repositories. But as researchers and people working in this field, we're increasingly able to access a lot of this contextual data that allows us to understand places, not just the spatial dimension that we're looking at. And so this led to sort of more interest from my side into this discussion about k-anonymity. So there's a lot of work in k-anonymity historically, quite a bit, and we saw in the last presentation some work sort of leveraging or building on top of k-anonymity and the various versions of that. And I'm really more interested in sort of saying, well, what do we know that we can leverage from the placial dimensions? So dimensions outside of purely just space in terms of geographic or geometric space, to better understand how we can anonymize data sets, considering that we know other information about data as well. And so k-anonymity has been described as a privacy protection concept. Really, the idea is that you should not be able to indistinguish somebody or some record in a data set from other individuals or other records in a data set. And there's various ways that we can do that. And so it's traditionally focused on a non-spatial domain, but increasingly we have spatial approaches to this that look at sort of clustering behavior or look at distribution of points in space to then try to identify an individual in a data set. Now, in an example like this, we have some points on a map, and that's pretty geometric in terms of its ability to sort of question this data set. But in reality, we know these points actually exist in physical space. And so they exist in physical space, which means they have attributes associated with them and the types of activities that people do at these types of places, right? So I'm talking specifically about places of interest here, and I've got some examples of from Google or from Foursquare or some of these place data sets where we have categories of places. And knowing a category of a place is actually very indicative of a lot of things. We know that we're creatures of habit, and we also know that there are things that are true for specific types of places, right? So hours of operation for places. We know how popular places are based on sort of how often people go to these places or what they do at these places. We also have popular times for places, right? So we look at the temporal popularity depending on the time of day and day of the week. And we can take these data and we can then ask the question, if we were to use these data how would we use these in order to improve our ability to de-anonymize a data set? So how can we leverage this contextual information, this is sometimes referred to as linkage attacks, to then further identify an individual in data set, or like the visitation behavior of somebody to a specific place? And the question is, well, if we just have time, right? So we have some temporal dimension, and we have all of this publicly available data that we can access through hours of operation, popular times, and popularity, how can we leverage that data to then improve this model? So if we don't have time, we know that there's a 1 in 30 chance of us being able to identify somebody in a 30-point data set right here, right? So if we just randomly pulled out a point, if we have 30 places, our chance is 1 in 30 in this case. But what happens if we include the temporal dimension? So if we know Friday at 7 p.m., what we can actually do is look back at the different dimensions of data that we have, the temporal dimensions, the popularity dimensions, the hours of operation. And all of these have probabilities for how likely somebody is to be visiting a place at that specific time, right? And so we can take these data and then use these probabilities to then re-rank our prediction model, our estimation model, to try and estimate where somebody is, what time of day, and what they're actually doing. And it turns out that actually does a pretty decent job. So we can actually improve our ability to de-anonymize a data set, or identify an individual in a k-anonymized data set by up to almost 40% in some cases, purely based on knowing the time that the general person visited certain places. Right, so if we have the popular times behavior from Google or from Foursquare, we can pretty easily figure out that we can, or I should rather say, we can decrease the randomness in this case of the data set and further de-anonymize the data set purely based on that. And we can take this a step further, right? So we can then say, well, if we include different types of data, like Foursquare popularity times, which is based on when people check into certain places, looking at Google popularity times, which is a much more passive sensor approach, where Google sort of pings your phone every once in a while to figure out where you are. We can look at hours of operation, and we can look at place popularity as well. And we can look at all of these different measures and say, well, how do each of them improve our ability to de-anonymize somebody in data set? And they all have various degrees of contribution to this. And it turns out popularity, which is a non-temporal pattern, actually does quite well. At a K of 30, you have almost 130% improvement in the ability to de-identify somebody in the data set. And then we can actually also take a weighted or combined approach to do that. So there's some various methods for combining these different approaches or different weights to then look at sort of what, if we were to combine all the different methods, how well could we de-anonymize somebody in the data set? And it turns out we can do it pretty effectively in a lot of cases. And so we did a sample of this over about 20,000 check-ins, so people visiting specific points of interest in the social media application, and found out that this is at a pretty drastic improvement in de-anonymization. You could put that as the negative, so it's a negative ability. So the anonymization of the data set decreased substantially. But it's important to just generally look at this and say, well, what can we do with freely available, like, public data on specific places, points of interest that are out there today? And then our question was, then, if we have this idea of k-anonymity, how do we improve k-anonymity, or actually truly make it anonymized by having our measure of placial k-anonymity? So, I mean, what do we need to increase our k by in order to maintain the same level of k-anonymity promised by a geometric k-anonymity measure? And so we did a calculation here and reporting in the table, and we actually have this in the original paper as well, where you often have to increase by substantial orders of magnitude the number of POI to include in your data set in order to maintain k-anonymity, given that we have access to additional contextual data. So the takeaway from this, from my perspective, is that we don't live in a vacuum. Unfortunately, as researchers, we often tend to approach the world as a vacuum and restrict the bounds on what we can actually collect data, and then ask questions specifically of those data sets. But we know that in the privacy domain, there are these concepts of linkage attacks, where we have access to data sets and we don't even know what new data sets are going to come out for us to be able to actually explore this data with. So we need to have new methods to preserve privacy location that consider other data sets that might be out there. I just, as an example, using 3 additional data sets, but there's a lot of other work that needs to be done in this. So we need better user-driven applications to expose people to this, to educate people on some of the ways that their data can be de-anonymized. And then we also need better approaches in general, often switching gears to look at things like homomorphic encryption to explore privacy preservation outside of the realm of things like anonymity. So I will leave it there. Thanks very much.
Thank you so much, Grant. And we know Grant is also recruiting a master's student in this area related to cryptography and geoprivacy. So if you're interested in this topic, make sure to get in touch with Grant. Okay.
Yes, thanks, Hongyu. I should have mentioned that, but thanks very much.
Our next speaker is Yifan Yang from Texas A&M, and he's going to talk with us about GeoLocator, a location-integrated large multi-modal model for inferring geoprivacy.
So my research is focused on GeoLocator, a location-integrated large multi-model for inferring geoprivacy. And my name is Yifan Yang. I'm really happy to have this opportunity to present here, and thanks for Hongyu's invitations. And for this year, I'm just the first-year PhD student. And the first part is about the background of my research. I think the background of my research is happened on a Reddit post. It is a very interesting story. As you can see for this poster, it said that he spent the last 6 months and over 300 hours trying to find a photo of followers and that is passed away in an accident. However, he spent lots of time on finding his father's places. It is really difficult to find it. However, once he posted his images to the YouTube, it's only spent 1 hour to find it. And after this research and after this very interesting story, and I think that since the humans have such abilities to infer some geolocations, infer some address from images, can computers or the AI can learn human analytical thinking to reproduce this process. At the same time, I also want to know whether the recently very popular large languages model and multi-models can really understand the street view images. So it is really interesting research topic and research questions. So after that, I do a research to compare with so many different large languages models, and the rest of the large languages model and multi-modal models can help us to do lots of these things. And more companies and researchers are focused on the research about it. And at present, there are already have so many closed source and open source large multimodals. And with the rapidly development of these models, and what these models can do, and what these informations can be inferring from these large models, is really a very interesting questions. And I also think that although the large languages models are black box algorithms, but however, they also have the problems about the interpretations and reasonables. But we still can use large languages model, and we still can use large multi-models to help us lots of things. So after I compare with this model, I found that, for example, GPT-4, they can understand images, and for the Rika, they can even they can understand the videos. So how about try to use the how about use GPT-4 to infer some geoprivacies from the street view images? After I have this sort and this research ideas, and I design a geolocator. So what is a geolocator? And geolocator is based on the GPTs. So the GPTs means that it is just a kind of the versions of ChatGPT. It's discovered and create customer versions of ChatGPT to combine with the instructions and additional knowledge and any skill on it. So I use the GPT to develop the geolocator, which can focus on the inferring locations of upload photos and give the accurate address information and coordinate information. For example, I upload the images. You can see this images has a sympathy, and my geolocator can analyze these images and give me some very key details. For example, he found the sympathy rate. Maybe it's in the Universal Studios. He will give the details and reasoning and help me to inferring the address and the coordinate. And after that, I make a very short videos about how to developing a GeoAI tools through ChatGPT. we can go through these videos. For example, so I just give you very quick through. So I think it is from the GPTs, and you can design your own your own GPTs. My GPTs is GeoLocator. Main ideas of this video is just you can upload any pictures you take by yourself or just from the street review. You can just open it and upload to our tour, and it can give you the analyze and give you the very specific address. And the key of this the key of this geolocator is it's all about the it's all about the instructions. The instruction is very important for the geolocator. So you should pay attention how to make a very detailed instructions. As for my research, I provide the very basic and very additional knowledge for my geolocator, and I also select so many different functions from web searching and image creations and data analyze. And also I give the background of my models. I define my model's role is in open source intelligence frameworks, and it can really good at the geographic questions. And also I clarify the purpose in a very clear languages. And also I try to build the detailed instructions based on the different and various aspects. And I want to the GPT, and I also want the geolocator can analyze my questions step by step. After I said about these instructions, it can have so many functions. You can say it can analyze the street view images. It can also do the image processing. It can also use the API to help me to get a better result. And the workflow to develop this tool and how this tool analyze these images, you can say these images. For example, we try so many different kind of the images. We try to use the landmark. We try to use different angle images, and also we try to use street view images. And we try in different time. For example, on the daytime and on the nighttime. And we also choose so many examples on the social media posters, and we put all these images into our geolocator, and our geolocator can analyze these images step by step. The first step is examine the visual and details, and secondly, they will find so many architecture and what is the vegetations and what is the street sign and what is the skyline, and my geolocator will give the initially hypothesize, and then the geolocator can use an online resource to refine the hypothesis. It will use a Bein to cause validations, and also try to use a Google Earth API to compare with the result. And the final goal is that whatever the images you can upload, I also give you the longitude and latitude and the street address about these images. And we try to compare with different platform. For example, we compare with the Google search engine, GPT-4, and our own design tool. And we found that the geolocator can analyze the pictures, can infer this images address very great. And you can see this is the result about use different images. For example, we try to use street view images, and the distance, it means that the distance differences between the real locations and the inferring location. So I think this result is really amazing, because as for humans, we cannot infer the address from the images, because we don't have the enough backgrounds or geographic knowledge, so we cannot to give the answer, but the geolocator can give us. However, it makes me feel uncomfortable because I think about the privacy issues. And combined with my research, I also read a very interesting article. It's published on the 2023 on the archive. It's based on the text. It's based on the languages. So it means that there are so many descriptions on the Reddit, and they use the ChatGPT and they use the large languages model to analyze the paragraph. And you can say they can extract so many informations on this texts. For example, they can know that they can inferring the personal attributions. They can inferring the age, and they can inferring the locations from these descriptions. So I think combine my research and with their research, maybe we can design a multi-models. For example, the input data will be not only the text data, but also use the image data. So our privacy, it can really easy to referring your privacy. So because there are so many scenarios in our social medias, we use social medias almost every day. I like to post my images, and I also like to post my my feelings on the Instagram. But however, maybe some people can use large languages model, can use this large multimodal to analyze which days where I stay. So it is really dangerous. So after that, I think there are so many summary and perspective. The first point, I think it is really it has a really strong capabilities, and there are so many potential applications of large multimodals in geographic. For example, it can be used on urban planning and smart cities. It can be used on disaster risk assessment and vulnerable analysis. And it can also use climate change and environmental monitoring. But also, it will also let us to think about how to provide us informations, how to provide and protect our personal informations to don't let the large multimodals to analyze. So it is really difficult. And the large multimodals will give us so many privacy issues. For example, the geolocation privacy and social medias and users' data explorations. So it is really difficult for us. So we should think about how to design really good algorithms to protect our privacy issue, especially on our geolocation privacy. It is really important. Okay, and thanks for your listening, and any questions and comments.
Thank you, Yifan. I think we have one question from Yifan. So Yifan asked, can the geolocator deal with changes in the environment, such as destroyed buildings in conflict zones? This is a large use case of geolocation. Yeah.
Yes, it can be used. Yeah, I also do the very similar research about use the large languages model to inferring the damaged places. For example, there are so many hurricanes in Florida state, so have so many three images on it. But if I can inferring the locations about damage street review, it can help a lot. So I also do the same research on it. And if you like to know more about it, maybe we can have a more connection on it.
Thank you, Yifan. So in the last 5 minutes or so, let me quickly present what I prepared for today's session. All right, so hopefully everyone can see my screen. So to conclude our session today, I'm going to quickly talk about geoprivacy knowledge, attitudes, and behaviors in contemporary China, which is one of the chapters in my doctoral dissertation. And the article has recently been accepted for publication in Geographical Review. So the motivation of the study starts with people's geoprivacy concerns during the COVID. However, people's view on geoprivacy may have changed in the post-COVID context. We chose China as the study area as it has an internet penetration rate of over 70% and a massive user base of social media. However, the topic of geo-privacy attitudes among Chinese individuals remains understudied. To the best of my knowledge, this is the first study to explore the regional differences in geo-privacy concerns within China. So the study aims to answer the following research questions. What factors moderate individuals' privacy knowledge and attitudes? Do privacy knowledge and attitudes influence privacy-related behaviors? And finally, whether the introduction of the new IP location feature change individuals' privacy behaviors. If you're unaware of the feature, since April 2022, all the major social media platforms in China have started implementing the IP location feature, which would make the IP location of users mandatory on all of their posts and comments. For users located within the country of China, the IP location would be displayed at the provincial level. So we developed the following research model. On the left-hand side, we hypothesized that females and older adults would demonstrate more pronounced privacy protection behaviors, while the regions of origin would not have a statistically significant impact, because we would assume people are coming from the same country and share the same culture. On the right-hand side, we expect a positive relationship between privacy knowledge, attitude, and behavior. So I designed an online survey comprising 22 questions, and the following sections were included, such as internet experience, geo-privacy knowledge, attitudes, and behaviors, the demographic questions, as well as attention check questions. We hosted and distributed the survey on Gridamo, a survey platform with more than 3 million users, and collected the data from the end of 2022 to early 2023. After data cleaning, 491 responses were left for subsequent data analysis. In the study, I implemented ordinal regression using backward elimination based on the ordered categorical variables extracted from the survey. And you can quickly glance through the sample characteristics of my respondents. And let's skip this slide. So let's quickly talk about the results. In terms of experience, knowledge, and attitude, they positively influenced respondents' privacy behaviors. Prior experiences of privacy incidents led to an increase in geo-privacy protection behaviors. And the greater knowledge about location spoofing resulted in less frequent labeling of location services. A higher degree of privacy concerns consistently corresponded to a higher degree of privacy protection behaviors. Female respondents possessed less privacy knowledge but more privacy protection behaviors, in contrast to their male counterparts. The impact of age on privacy concerns was inconclusive. However, we did find that older respondents possessed higher level of declarative privacy knowledge. Here, declarative privacy knowledge means knowledge about privacy rights and privacy laws, which consistently decreased respondents' privacy concerns. Notably, we identified regional differences in privacy concerns within China, especially in Northeast China. This area consistently exhibited the lowest level of privacy knowledge and concerns, as well as a relatively low level of privacy protection behaviors. Respondents from East China preferred the coarsest geographic scale of IP location, while responses from Southwest and Northwest China exhibited the highest level of geo-privacy protection knowledge, behavior, and attitudes respectively. We also observed privacy paradox. So although respondents had relatively strong location privacy concerns, some of them didn't exhibit a high level of privacy protection behaviors and still shared their locations frequently. Finally, we also found that people's privacy concerns were platform dependent. So Douyin users, for example, demonstrated fewer privacy concerns and more frequent location sharing, likely because Douyin is primarily a short video platform, while Weibo and WeChat users chose to act contrarily. This is likely because WeChat, for example, is predominantly a messaging app for maintaining social ties with friends and families. So this study fills the research gap of geoprivacy concerns in China, and from our analysis, Chinese citizens care about their geoprivacy and act following their privacy attitudes. So finally, I would like to thank the Quebec Research Fund, the Spatial Analysis Lab, and the Geography Department at McGill to support my research. So that concludes my presentation. Since we are already running out of time, I would like to thank everyone who participated in today's geoprivacy session. Thanks all of our wonderful symposium organizers to troubleshoot the technical difficulties, and thanks all the panelists for their insights on this topic. And we'll make sure to continue this discussion in all the future symposium and annual conferences.
Thank you, Hongyu. Thank you so much for the presenters. It's a very exciting session. Thank you, everyone.